we have the pre-knowledge of this one is that we've done all of these ones before. So what's log base 2 of 2? 1. Okay. Log base 2 of 2 is 1, because you say 2 to what exponent gets me 2? 2 to what exponent gets me 4? Log base 2 of 4. 2. Log base 2 of 8 is 2 to what exponent gets me 8? 3. And then this one's 2 to what exponent gets me 16? 2 to what exponent gets me 32? 5. And then 6, 7, 8. All right. So, these laws of logs are actually on your formula sheet. They're under the laws of logarithms. We're going to look at the top 3. The bottom one you've already done before. So, if you do the old calculator, that's how you have to type it in. So, log b of m times n, we can take two things that have the same log base. We can put them together by multiplication. But let's see how that even works. So, if I go log base 2 of 4, I get 2. And if I go log base 2 of 8, I get 3. And if I go 2 plus 3, I get 5. We agree? Now the rule on my formula sheet for the product rule says that if these are the same base, so they're both base 2, and they have plus 1s in front, I can multiply them. So let's try it out. I can write it as a single logarithm. I can go log base 2, and then I can go 4 times 8. So that's the rule. If I have a plus sign between them with 1s in front, and the base are the same, I can put them together in multiplication. Now this becomes log base 2 of 32. What's log base 2 of 32? 5. Same answer. They end for the exact same answer. So it is true that you can do that. That's the same work. We're going to look at number 4. So this one is log base 2 of 32. What's log base 2 of 32? 5 plus log base 2 of 8, 3, and 5 plus 3 is 8. So now, if we have log base 2 plus 1 in front, plus 1 in front, I can put them together by multiplication. So log base 2 of 32 times 8. Which is log base 2 of 256, which is 8. We have it up there. So they match. I'm going to bypass this little thing and go right to here. This is called the multiplication law or product law of logarithms, and the general case can be given as this. So if I have a plus 1 in front, log base A, plus 1 in front, log base A, I can put them together by multiplication. Most people will spot that they can put them together as a single logarithm, but they forget that they can pull them apart too. So if I have log anything multiplied beside each other, I can separate them by addition. I can make them be separate logs when I have that multiplication. So let's look down here. I have log base positive 1, log base 2 of 15, positive 1, log base 2 of y. So they both have plus 1s in front, and they both have base 2. That's my stipulation in order to be able to use the product law or multiplication law. So I'm going to get log base 2. And then because this one has a plus 1 in front, 15 can be multiplied by y. And when they have plus 1 in front, they go in the numerator. When they have minus 1s in front, they'll go in the denominator because we're going to divide. These both have plus 1s in front, so they go in the numerator. So I literally just have log base 2 of 15y. And most people will spot to put them together if they have the same base because it kind of screams put me together. But what people forget is that they can take them apart. So when I see log base 3 of 9xy, I will write that as log base 3 to help myself out. People will think the 9 and the x are attached. No, none of them are attached. They're all multiplied. So I have a 9 times an x times a y. You see that? So I literally write them out with multiplication dots to remind myself that they are being multiplied. So if they are being multiplied, which means they're in the numerator, I can separate them all with plus 1 logs. So I can rewrite this as log base 3 of 9 plus positive 1, because these have plus 1s in front if they're in the numerator, right? Plus 1 log base 3 of x plus 1 log base 3 of y. Now, do I need to write those plus 1s in front, or is that for effect right now? It's for effect. It's so that you see that there has to be a plus 1 in front. Now we can keep going. Why? Log base 3 of 9 is something. What is log base 3 of 9? 3 to what power gives me 9? 2. Log base 3 of 9, if I punched in my calculator 2, I would get a 2. It's an actual number. And then they might write it like this. Log base 3 of x plus log base 3 of y. The problem with the exponent and log unit is not that the stuff is hard to do. It's that you have to try and match what they have. So they could have this as their answer, or they could have turned this into a 2 and then put these two back together. Log base 3 of xy. Both of these are equally good answers. Which one's better? The one that matches if it's a multiple choice or numeric response. Like it might say in the form a plus log 3xy or something like that, right? Like it might give it to you in a specific form for a numeric response. What's the value of a equal to b2? Then we're going to flip over. So now we have the quotient or division law. So it's just a subtraction sign. So this one has a plus 1 in front, and this one has a minus 1 in front. So we get log base 2 of 8 is 3, minus log base 2 of 4 is 2, 3 minus 2 is 1. Now our rules are that they have to have the same base, so they do, they have base 2, and anything with a plus 1 in front goes in the numerator, and anything with a minus 1 in front goes in the denominator. That's how you get the division. So the log 2 base 8 has a plus 1 in front, so my 8's going to go in the numerator. And the log base 2 of 4 has a minus 1 in front, so the 4 is going to go in the denominator. And I'm going to get log base 2 of 2, which is what? Which matches the same answer. You try 4. Here we have log base 2 of 32. That equals 5. Minus log base 2 of 8. 2 to what power is 8? 3. 5 minus 3 is 2. Then this has a plus 1 in front. This has a minus 1 in front. So this is going to go in my numerator. And this is going to go in my denominator. Only because they all have the same base. If a couple logs have the same base and another 2 logs didn't have the same base, you can only put together the ones that actually do have the same base. Then you have more than one log left over. That's how it would go. So here we have log base 2. 32 in the numerator, 8 in the denominator, and so I get log base 2 of 4, which is 2. Same answer. So here it shows that quotient rule. Log base a of m minus log base a of n, positive 1, negative 1. The n went in the numerator and the n went in the denominator. Once again, it works in both directions, so if I have two things divided, I can separate them with a subtraction test, right? And we might have more than just 2 logs put together after this. Well, we will have more than one. So here we have log base 2 of 15 minus log base 2 of y, plus 1 in front, minus 1 in front. If they don't have 1s in front, we're going to learn power rule right next to this, and how we can get that number to move so it actually stays a 1. So here we're going to get log base 2, 15 over y. The 15 goes to the numerator, it's a plus 1 in front, the y goes to the denominator. Now b, people will look and be like, I don't know what I can do. It's all together. Well, you can expand it, correct? You can make it further out. So you'll get log base 3 of 9 minus log base 3 of x. And then what is log base 3 of 9? 2. 2 minus log base 3 of x. Then we're going to flip over. Oh wait, so we have the power law, which is below the quotient and product on your formula sheet. It basically says log b of m to the n equals n log b of m. So if you have an exponent beside what's beside your log, it can drop in front, or if it's in front, it can be brought up. But let's show how this actually works. So if I have, what we're trying to show is, if that rule is true, log base 3 of 2 to the 5, I can take this 5 and drop it in front. It should equal 5 log base 3 of 2. This is what we're trying to prove with actual numbers instead of variables. Okay? We're trying to prove that we can take that exponent and drop it in front, or we can take it from in front and bring it up as the exponent. So if I have log base 3 of 2 to the 5, that means I have I have 5 2's, correct? So I can go log base 3 of 2 times 2 times 2 times 2 times 2. So instead of writing 2 to the 5, I can write 2 times 2 times 2 times 2. Same thing, correct? Then using the product rule, I can take anything that's multiplied together and separate it as a single log. So log base 3 of 2 times 2 times 2 times 2 times 2, I can rewrite out as log base 3 of 2 plus 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 log base 3 of 2. How many log base 3 of 2's are there? There are 5. So if I add these up, if I go log base 3 of 2 plus 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 log base 3 of 2, I would get 5 log base 3 of 2's. So what did I just prove? I proved that I can go from this to this. So this to that, which means I could also go backwards. The same thing. So log base 3 of 2 to the 5 is equivalent to 5 log base 3 of 2. So only if there's a log existent. Some people try and do it with exponents. They're like, I'm just going to drop it in front because it's an exponent. No. You have to have a log, and that has to be in the bracket to that exponent that it can drop in front or come up as the exponent. It's called the power law. So I can either take my exponent and drop it in front, or I can take my variable and bring it up, or my coefficient and bring it up as the exponent. Works in both directions, just like all the other equations we have on our formula sheet. So if I have log base 3 of 9 squared, I can write that as 2 log base 3 of 9. And it might be easier to do that way, because then this is 2 log base 3 of 9. Well, that's equivalent to 2 times what? What is log base 3 of 9 equal to? 2, because 3 to what power is 9, right? So it'd be 2. So it'd be 2 times 2, which is 4. Then this one, if I have the k in front, I could bring it up here. So I could write it as log base 2 of a to the k. So like I told you, exponent and logs are not hard. You might just have to have it in to convert it to some form that they have that you didn't think to do. So they maybe have the k up instead of the k in front. Now, when I said to use product and quotient, product and quotient rules can only be used if you have plus 1's in front, correct? Or minus 1's in front. So now if I have a number in front, I just make sure that I bring it up to the exponent using power rule, and then I can just do what I just did on all the questions. So, this just summarizes all the formulas again. We're going to flip over here. We're going to do some questions now. So I have log base 3 of root 27. Does anyone remember how to make that root 27 not be a square root? Yeah.
No, is the 3 just times it 9 by 1 times 3?
Nope. We want to get rid of the root, not reduce it. Nope, we want to get rid of the root. Grade 10. How do you write root 27 not as a root?
9
Times
3,
it by root 27?
and then you take the...
Nope, you just have what Keegan said. Grade 10. This is to an exponent of what? 1. This is an index of? Drop it underneath. 27 to the half. Cube root is to the third.
No language, no.
Grade 10 lesson. So we're writing from radicals to rational exponents. It was a lesson in grade 10. You would go from a rational exponent to a radical, or a radical to a rational exponent. Remember how I said grade 10 is so important? Comes up all the time.
Lovely.
So, we can, whenever we get a radical in these, we will rewrite it as a rational exponent. So it's log base 3 of 27 to the half. Now, if I want to do, I don't know what 3 to what power is 27 to the half. That's hard to do. But I can drop the half in front now, and I can write it as half times, technically, log base 3 of 27. What is log base 3 of 27? A half times 3. When we multiply fractions, always put a denominator so you don't multiply wrong, and we get 3 halves. Now, some people may say, well, Mrs. Lepp, I can just type in my calculator and give me 3 halves. Cool. They're going to put a variable in there, so you can't. So, I look at number 2, I'm like, sweet. Log base 2 of 16, half log base 2 of 16, 1/3 log base 2 of 8, log base 2, it screams, put me together, every time. Okay? And then I'm like, okay, cool, I have rules. If I want to put them together, they have to have the same base and they have to have 1s in front.
Oh no.
Oh no, they do not. What can I do?
Divide.
What is 1/16 or how many eighths of 1?
Bring it up as an exponent. So I'm going to get log base 2 of 16 to the half in the brackets minus log base 2 of 8 to the 3rd in brackets. Now, like I said, you're like, I can type this in. Cool. They're not going to let you. So we have to go through the rules. They're going to put a variable in, so you can't type it in. So now I'm going to get log base 2. What's 16 to the half? Without typing it in.
8.
4. Because anything to the half is just the square root of something, correct? So it's the square root of 16, which is 4. Minus log base 2 and 8 to the 3rd
It's just 2.
is just 2 because it's the cube root of something. Oh boy. So we have log base 2, log base 2. Now guys, remember how I warned you about like when we did like the addition and subtraction formulas in trig, and I told you you're going to write sine theta, sine 2 pi over 3, and you're going to keep the signs, and I told you you have to get rid of them and replace them completely fully. Remember how I said that, and then you didn't listen, some of you didn't replace them with test? Same thing here. Do you see how I did not take the minus sign up? Do you see how I just took the coefficient up? I didn't go and put this to the negative 1/3. If you do, you're making your life harder because you're raising it to a negative exponent, and then you're going to have to flip it to make it positive in the end. You're just making yourself more work. So I just take the number, not the actual symbol. Do you see that? So now I have log base 2 of 4 and log base 2 of 2, so I can go log base 2 of, this has a plus 1 in front, so the 4 goes in the numerator. This has a negative 1 in front, so the 2 goes in the denominator. So I have log base 2 of 2, which is 1. Now I know you could have just typed it in, and you could keep repeating that to me the whole time. But we are going to have variables, so we can't just type it in, right? They're not going to just test your calculator skills of typing in a lot. Okay, here's some variables. Now, I have log base 2, log base 2, log base 2, log base 2, which screams, put me together. But in order to put them together, I need to have what's in front? 1s. Plus 1s or minus 1s are fine, but it has to be 1s. So this one has a 1, this one has a 1, this one does not. So I have to bring the 2 up here and put it in brackets. Now it has a 1, and this one has a 1. So I technically have equal to log base 2 of x plus log base 2 of 2x, and this should be equal to, because these are expressions, not solving, so this equals this, equals this, equals this. You should have equal signs running down the left-hand side. Minus log base 2 of x squared minus log base 2 of y. Now they all have, this one has a plus 1, minus 1, minus 1, base 2, base 2, base 2, base 2. So my rules are good. I can now put them together. So I'm going to get log base 2, and anything with a plus 1 in front goes to the numerator. Anything with a minus 1 in front goes to the denominator. So this log base 2x has a plus 1 in front, so my x goes to the numerator. And this one, log base 2 of 2x has a plus 1 in front, so my 2x goes to my numerator. And then it's multiplied always. Always multiplied if you have more than one thing in the numerator or denominator. And then this one has a minus 1 in front, so x squared goes to my denominator. And this one has a minus 1 in front, so y goes to my denominator. And then I have more than one thing, so they're multiplied. So now I have log base 2 of 2x squared over x squared y. Can I do anything else? These are multiplied, so then I'm allowed to cancel, right? If there was a plus or minus sign between them, I couldn't. Because they're multiplied, I can cancel them. And so I'm left with log base 2 of 2 over y. Now this is a perfect answer. I like it. Oops, I just tried to fully color. This is the perfect answer. I like it, but it's not the answer that's there. Like that might happen, right? You get an answer and you're like, sweet. And then you go to multiply and you're like, dang, it's not there. Is there anything I could possibly do to this to get a different answer? Because this might be the answer, it might not be. Yeah?
Can you just do, like, flip it so you get y?
No. You're saying y is an 81. Yes, you could, but that wouldn't, yeah, that's not one point. But you could do that, yeah.
Log base 2 minus log base
Yes.
2.
So we can separate these back out again. Because log base 2 of 2 is going to give me a number. So we could go log base 2 of 2 minus log base 2 of y. What's log base 2 of 2? 1. So their answer might just be 1 minus log base 2 of 1. Is this answer any better than that one or that one any better than this one?
No.
No, but you're trying to match multiple choice. Okay. We're going to do this one here, because it has variables. Try it out. So like I said, if they don't have a base, I put base 10 to help myself out to realize that they're all the same base. Because when they're all the same base, screws put me together. Then I bring the 3 up, and I bring the half up, not the sign. So now I get log base 10 of a times b cubed over c to the half, because it's minus 1. And they'll often rewrite this as log base 10, but they won't put the 10. ab cubed over the square root of c. And we'll leave it. No, you only plus minus when you physically take the square root of something, like when you're solving. So like if I had a squared equals 7, and then I would square root to get rid of the a squared, then I would put plus or minus. So it's solving. Yeah. Okay. Look at these. Example 3 and example 4. I want you guys to try them out. This one's an expand. I'll do this one first together, actually. So this one is log. Now, remember, I told you, if it doesn't have a base 10, if it doesn't have a base, sorry, put base 10 because it often helps you out. I will always do it. So this one I'm going to get log base 10 of 100, which if I didn't put the base 10, that wouldn't scream to me that that's the answer of 2. So that's why I put the base 10. Log base 10 of 100 plus log base 10 of a plus log base 10 of b squared. And then log base 2 of 100, or 10 of 100 is 2, plus log a, because they won't write the 10. And then they'll probably drop the 2 in front. So plus 2 log b. So you guys are working on all these examples down here. I'll give you about 10, and then we're going to go through them. So this one here, we have to remember that the 25 is being multiplied. So we get log base 5 of 25 plus log base 5 of m cubed minus log base 5 of n because it's division. Log base 5 of 5, or 5 of 25, sorry, is 2. Then we can drop this in front, plus 3 log base 5 of m minus log base 5 of n, which is c. This one, if it's the square root, it's to the 1/2. If it's the cube root, it's to the 1/3. If it's the b root, it's to the 1 over b. Right? You just drop that b under that one exponent. So I get log base a of a to the 1 over b. What do we do when we have the same thing? Log base a of a to the 1 over b. What's your answer? The exponent. So if I had log base 2 of 2 to the 5, I would say 2 to what power gets me 2 to the 5? You'd say 5. Right? Using the rule we learned today, we could also drop that 5 in front. And we could say 5 times log base 2 of 2. What's log base 2 of 2? 1. So I could do that here too. I could drop that exponent in front. I could say 1 over b times log base a of a. And what's log base a of a? 1. So that's 1 over b. 3. We have to bring this up. We have to bring this up. So I get log base x of 4 cubed, which is 64, plus log base x of 8, minus log base x of 16 to a quarter is the 4th root of 16, which is 2. And now they're all base x, so I can put them together, and they all have plus 1s and minus 1s in front. So I get log base x. 64 goes in the numerator because there's a plus 1 in front. 8 goes in the numerator because there's a plus 1 in front. 2 goes in the denominator because there's a minus 1 in front. And I get log base x of 256. Now I star number 4 because I see it a lot all over the place, and people do it terribly. So I know that if I had log base a of 5, I could fill in 7. And I know if I have log base a of 3, I can fill in 8. We agree? But I have log 75. Is there any way I can split 75 into 5s and 3s?
Yeah, 25.
2 5s and a 3. I could go 25 times 3, right? So I could go 5 times 5 times 3. So I can rewrite this as log base a of 5 times 5 times 3 times a squared, technically, right? Then I can expand them with plus signs. So I get log base a of 5 plus log base a of 5 plus log base a of 3 plus log base a of a squared. Log base a of 5 is 7. It says it up there. Plus log base a of 5 is 7. It says it up there. Plus log base a of 3 is 8. And then what's log base a of a squared?
2.
It's just a 2. And if you don't see it, you could bring the 2 out front here, and then it would just be 2 times log base a of a, which is 2 times 1. Right? Because log base a of a is just 1. So this is going to be 2, which is 20. Then these have plus 1s in front. So I'm going to, and they're base 10. I put the 10 in so I remind myself that they're the same base and I can put them together. So I guess log base 10. The x and the x plus 4 are both in the numerator. So I just get log base 10 of x squared plus 4x, which is b. This is a plus 1, this is a minus 1. So I'm going to get log base and base 10, so I see that they're the same. Base 10, x squared minus 4 in the numerator, x minus 2 in the denominator. Am I done then? Yeah, what's x squared minus 4? The difference of squares. So I'm going to get x plus 2 and x minus 2 over x minus 2. get log of x plus 2. And I box it because I'm proud of it. Same thing with this one.